All right, guys. Today we are doing a lab in the classroom called the weathering lab, and you see this on the agenda for today. I'm going to kind of walk through the lab, give you guys some numbers, explain what we're doing, and just kind of describe what to do on your end. You're going to need to just fill this out. You can either type it up or print it out and write it up and send me pictures back. But let's just start at the very beginning. This is lab number 13. You'll see it says part A is the abrasion of sugar cubes. So this is kind of mimicking what happens in a stream. This is a sugar cube. Okay, it's a pretty cubical looking thing. It's solid sugar, and it's pretty soft, so it'll break up pretty easily. The first part of this lab is to measure the length, the width, and the height of each cube, which I'm doing on the screen right now. And it looks like the length is 1.3. And so if we assume, we can make the assumption that all of the cubes are the same, and the width is 1.3 as well, and the height is 1.3 as well. So it is a perfect cube. And so what you're going to write down here, I'm just going to write it off the side here. Length, width, and height. You can see step 1, 1.3 times 1.3 times 1.3. Okay. And if all of the cubes are all the same, we can multiply that by 5, as it says right there, multiply by 5, and that will give us the volume. Okay. So all you're going to do is use a calculator, multiply all those numbers, and that volume is going to go right over here in the table in this first box right there. Okay, so 1.3 times 1.3 times 1.3 times 5 is 10.985. And I'm just going to round that to the nearest tenth, which would actually give us 11.0. Okay, and that's centimeters cubed. Make sure you label your numbers in there. Now, the mass of all 5 cubes can be obtained by putting them on the balance, okay? And if you can see this on the screen, it's a little bit unclear, but the mass is 18.5, okay, grams. And then you just have to do the density by dividing 18.5 divided by 11, and that will give you the density of the sugar, which in this case is 1.68 on my calculator over here. You can barely see. Now it's on the screen, 1.68. I'm going to round that to 1.7 just to keep everything even, grams per cubic centimeter. Okay, so that's the first part of this, is just measuring mass and volume and getting the density. Now, before we do anything else, I forgot to do this hypothesis. What do you think will happen to the sugar cubes after shaking? So you're going to put them in this jar over here. Well, I am. Okay, you put them in the jar, and then you're going to shake them up. And I want you to just basically tell me, what do you think is going to happen to the density of these sugar cubes? Okay, so put them in there, and we're to shake them up. Okay, you tell me what's going to happen. So write that right there before I do it. Then you want to make sure that you draw the sugar cube every time you do it. But the original cube looked like that. Okay, pretty square shape. You don't have to go 3-dimensional unless you want to. Okay, and then you're going to shake it for 30 seconds, which I will do, and I will speed through this video a little bit, just so you guys don't have to watch me shaking, okay? All right, now that I've shaken that all up, I'm going to dump it all out on my paper here, including the powder, and you can see what happened to the cubes. They're much more round than they used to be. Okay, and now I'm going to take the mass of those things again, as it says in the procedure. So I took the mass, and now we're down to 15.0. Exactly, that's a nice number, 15.0. I'm going to sketch them. They look a little bit more rounded on the corners, okay? So it's more like that. Now, here's the trick. Can I figure out the volume of this thing with a ruler? Nope, I can't. Okay, there's no straight sides anymore. So in order to figure out the volume, I've got to do something a little bit different. I have to assume that density of sugar never changes. So this is always going to be 1.7 all the way down this column. Okay, so I'm going to write that there. And I'm going to assume that's true for all of these. 1.7 is always the density, because the density of sugar doesn't change if I just make it smaller. Okay, I'm not changing anything physical about this, or anything chemical about this. So it's always 1.7. Now, in order to figure out the volume, it says right here in the directions, volume is mass divided by density. So I'm just going to do a little bit of math here, and 15.0 divided by 1.7 will give me the volume of all of those cubes altogether, 8.8 centimeters cubed. Okay? And now I'm going to do the same thing all over again. I'm going to repeat this experiment. And again, I'll skim through this video, so you don't have to watch me shaking it. But that's what they're doing in the classroom. Okay, so I figured I'd show you what they're doing here. All right, dump it out again. All right, and you can see what they look like now on screen. Make sure my desk stopped shaking. I shook everything all up there. Let's measure the mass again. And you can see we're down to 12.4. I'm going to draw them again. They look a little bit rounder than they used to be, perhaps. And now I got to do the math again. So 12.4 divided by the density, 1.7. And that's going to give me 7.29. So I'm going to round that to 7.3. Okay. And one more time, I'm going to put them back in the jar, shake them all up again, and that'll be our last trial for all of these. And you'll get one more set of data. Okay, so shaking again. All right, a couple more. Put them all out again. Measure their mass, and you can see they're pretty nice round shapes now. Okay, this is exactly mimicking what happens in the stream to rocks over a longer period of time. Mass now is down to 10.1. They're almost circular. Okay, so we're going to just draw that shape. And then again, one more calculation here. 10.1 divided by 1.7. That's going to give me my volume of 5.9 cubic centimeters. Okay, so there we go. You can see how the mass is decreasing as we go down. The volume is decreasing as we go down over time. Obviously, I lost a lot of the sugar into this powder pile over here, and that's what happens in the stream as well. The rocks get broken down into smaller and smaller fragments, and all we're left with are these nice rounded shapes of the larger sediment. Okay, so everything's getting smaller over time. So that's part A of this, the abrasion of sugar cubes. Now we have a graph on the next page, which you'll see is a little bit different. Okay, it says a double y-axis graph. So you're going to have two lines on this graph. This side is going to be mass. This is going to be volume over here. And this is time. Okay, don't forget to put units on this thing. And this is seconds down here. Now we had 90 seconds total, so that's 0. I went 1, 2, 3, 4, 5, that's 30 seconds. 1, 2, 3, 4, 5, that's 60 seconds, and this is 90 seconds over here. Now, my mass decreased, and what I want to do is just set up my graph so that it includes all of my data. My highest mass is 18.5, so it would make sense to be like maybe 20 up here, okay? And work your way down and find a good scale that's going to fit to include it all the way down to 10.1, which is my lowest. So somewhere in this neighborhood should be around 10. Okay, so I want to just decrease my numbers there, or increase as you go up, only from 10 to 20. Okay, the volume starts at 11, goes down to 5.9. So you probably want a number maybe like 12 up here, going down to like maybe 5 down here. So find a good scale that will fit. I'll let you do that. Now, the one big thing about this graph is that you're going to have two lines, and you can do them either different colors or whatever. But okay, let's say the volume to begin with was 11. Well, on this scale, 11 is like right around here, right? But that's at time 0, so my dot is going to be all the way over here. So my volume line is going to be like this, and it gets a little bit lower. Here's at 30 seconds, right? And then at 60 seconds, and then at 90 seconds. So I'm going to have a line that kind of decreases like this, okay? My mass is going to start at time 0, start at like 18, maybe around here or so, and again, decrease. They're going to kind of be parallel to each other all the way down. You'll see how they work out with your different scales. So you use this scale for mass, my black line, this scale for volume, my red line, and you're going to have two lines that look like that. Okay, that's part A. Part B is chemical weathering. So now we're dealing with a chemical change, not a physical change, and we're not doing the sugar cubes anymore, but we are doing something with Alka-Seltzer. Now, if you've never seen Alka-Seltzer before, you can buy this from the store for pretty cheap. If you want to try this at home, go for it. I mean, ask your parents to buy some Alka-Seltzer so you can try this out. We have a whole tablet, a powdered tablet, hot water, and cold water. So we're testing two different things. This first part's all about surface area. If I have a whole tablet, here, I'll open them up so you know what they look like. Okay, a whole tablet has very low surface area. Okay, because we got two sides and then the edge. Okay, so it's looks like a coin, just a round tablet here. Okay, if we put this into water, which is what they're doing in the lab, I'm not going to do it here. Put it into water, it starts to break down. And I'll just play a video. I think I have a video right here of Alka-Seltzer and water. Yeah, we'll just play this quick video. You'll see what happens to Alka-Seltzer as you put it in water. There's a chemical reaction that takes place, and you can see all these bubbles that are being produced. Now we can speed up this process, or we can slow down this process by one of two things: either change the surface area or change the temperature. And that's what we're doing in the lab here. If we heat up the water, this reaction happens a lot faster. And so we have some numbers that we're just basically measuring how long does it take this tablet to dissolve. Okay. Now, back in our lab here, I'm going to just give you guys some numbers rather than doing this on the screen, because that would require me going over to the sink and actually showing you all that stuff. But if you want to try this again, you can do it at home. The whole tablet in regular water, like lukewarm water, room temperature water, took around 28 seconds or so to dissolve. Okay, and that was different for everybody, but about 28 seconds. That's 28 Fs. Powdered tablet. I took this tablet and I crushed it up into little pieces. That means there's a lot more surface area because there's more surfaces. So it's going to dissolve a lot faster. And the powdered tablet took anywhere between, like, I'd say about 10 to 20 seconds. So we'll just say 15 seconds on average. Okay, that's the number there. Hot water, cold water. Now, hot water dissolves the tablet a lot faster, and cold water is a lot slower, just because the water molecules are moving faster when it's hot, and therefore it breaks it down a lot faster. And so it was around 25 seconds or so for the hot water. And cold water, depending upon the temperature of the water, it varied across the class, but around 40 seconds or so for cold water. Some of us got snow from outside and went really cold, and that took a lot longer, but you can do it either way. And then all you guys have left are some questions. Okay, part A questions, part B questions, and then some conclusion questions regarding this whole entire thing. Okay. Now, if you have any questions about the questions, just let me know. But I basically have done the whole lab for you, and now all you got to do is fill it out. Okay. Hope you guys are doing all right, and hope this all made sense to you. Let me know if you have any questions.